Welcome to Cocktail Sort, also known as Bidirectional Bubble Sort. It fixes a weakness in classic bubble sort known as the turtle problem, where small elements at the far right take many passes to reach the left. Each round consists of 2 passes. A forward pass bubbles the maximum element to the right. Then a backward pass bubbles the minimum element to the left. The active region shrinks from both ends simultaneously. Let's watch it in action. Starting pass 1. Comparing 27 and 58. 27 is not greater, no swap needed. Comparing 58 and 82. 58 is not greater, no swap needed. Comparing 82 and 32. 82 is greater than 32, so we swap. Swapped elements at positions 2 and 3. Comparing 82 and 41. 82 is greater than 41, so we swap. Swapped elements at positions 3 and 4. Element is now in its final sorted position. Starting pass 1. Comparing 32 and 41. 32 is not greater, no swap needed. Comparing 58 and 32. 58 is greater than 32, so we swap. Swapped elements at positions 1 and 2. Comparing 27 and 32. 27 is not greater, no swap needed. Element is now in its final sorted position. Starting pass 2. Comparing 32 and 58. 32 is not greater, no swap needed. Comparing 58 and 41. 58 is greater than 41, so we swap. Swapped elements at positions 2 and 3. Element is now in its final sorted position. Starting pass 2. Comparing 32 and 41. 32 is not greater, no swap needed. Element is now in its final sorted position. Elements sorted and locked in place. Congratulations! You have successfully completed the cocktail sort lesson. Let's review what happened. The algorithm sorted the array in 2 passes. It made 10 comparisons each time it checked whether 2 adjacent elements were in the right order during a directional pass. It performed 4 swaps each time it had to move an element toward its settled end. The original array was 27, 58, 82, 32, 41. After sorting, the array became 27, 32, 41, 58, 82. Here are the key takeaways from this lesson. First, cocktail sort makes a forward pass to bubble the largest unsorted value rightward, then a backward pass to bubble the smallest leftward. Second, the active window shrinks from both sides every round, so both ends of the sorted region grow simultaneously. Third, in the worst case, the time complexity is order n squared. This happens when the array is sorted in reverse order. Fourth, the space complexity is order 1. It sorts entirely in place using only a few temporary variables, requiring no extra memory. Interesting insight, 4 swap. Now let's explore the time and space complexity of cocktail sort in detail. Best case O, n. On an already sorted array, the first forward pass finds no swaps and the algorithm terminates immediately. Average case order n squared. For a random array, cocktail sort typically makes fewer passes than bubble sort but still requires approximately n squared over 4 comparisons. Worst case order n squared. On a reverse sorted array, the shrinking window still results in order n squared comparisons similar to bubble sort in the worst case. Space complexity order 1. Cocktail sort is an in-place sorting algorithm. It only needs a few temporary variables regardless of the input size. No auxiliary arrays are created. When should you use cocktail sort? Cocktail sort is useful when you already use bubble sort and have turtle element problems with small values far to the right. It converges faster in practice thanks to its bidirectional passes. When should you avoid cocktail sort? Avoid cocktail sort for large datasets above 1000 elements, where its order n² worst case is too slow. For production systems, prefer timsort or intro sort. That's everything about cocktail sort. Well done on completing this lesson.